Okay, this is problems number 1 on your geometry pretest. Find the value of the expression where x equals 6, y equals 10. So we need to plug in wherever we see an x with a 6, wherever we see a y with a 10. 3 over 2 times x, which is 6, plus y, which is 10. We're not done yet. We need to simplify this. The easiest way to simplify this is, would you agree with me that 6 is equal to 6 over 1? So we're going to say 3 over 2 times 6 over 1 plus 10. When you multiply fractions, you multiply them across this way. So it's 3 times 6. What's 1 times 2? Sorry, 2 times 1, 2, plus 10. What's 18 divided by 2? 9 plus 10 is 19. Is that the answer? It's almost like I've done this 6 times now. Next one. Problem number 2. This one's a trickier one. Let's replace our variables. 6, 10, plus 10, 6. Here's the mistake people make. Your denominators need to be the same. The easiest way to get two denominators that are the same is to multiply them together. So it's 10 times 6. 60 for the first one, 60 for the second one. That's our whole goal, is to get these two the same. What did we multiply this bottom part to get 60? So we have to multiply the top part by 6. What's 6 times 6? What do we multiply this bottom part to get 60? 10. What's 10 times 10? 136 divided by 60, is that the answer? It's always embarrassing when I miss it. All right, it's actually not the answer. You're supposed to simplify that, but we're not going to go through that right now. This one, this is just a 2-step formula. Your algebra teacher should be proud of you if you can solve this. When you do this, you have to you try to get x completely by itself. So what we're going to do is we're going to unwrap it. First thing I want to do is I want to get rid of this 3. So we're going to do the opposite of adding 3, which is subtracting 3. If I subtract 3 here, I have to subtract 3 on the other side. 3 minus 3 is 0. 7 minus 3 is 4. 2x plus 0 is equal to 4. Is that proper? Should we write plus 0? Yeah, don't be ridiculous. It's extra work. 2x is equal to 4. We have 2 times x. Opposite of multiplying is dividing. So we're going to divide both sides by 2. Okay, let's look at this for a second. 2 divided by 2 is equal to what? 1. So we really have 1x is equal to 4 over 2. I don't care about that 1 there. You can just go away. X is equal to 2. Is that our answer? Oh, wow, it is. Imagine that. Last one. Now, let me know if I'm going too fast, okay? It's important to tell me. Especially, honest with you guys, 7th period, I normally go really fast because I'm tired of the lesson. So if I need to slow down, you need to tell me. Does that make sense? Because believe it or not, if you think this is boring, I've done this 6 times now. Okay. 3x minus 2 divided by 6 is equal to 4. Whenever you see a denominator in problems like this, you need to get rid of your denominator. What is this really saying? 3x minus 2 divided by 6. What's the opposite of dividing by 6? Multiplying by 6. 6, so we end up having these two cancel each other out. Why did they cancel each other out? Because 6 divided by 6 is equal to 1. 3x minus 2, remember these canceled out, is equal to 4 times 6 is 24. Right? 24? Pretty sure. We want to unwrap this. We want to get x by itself, so we're going to do the opposite of subtracting 2, which is adding 2. 3x is equal to 26. We're almost done. We have 3 times x. What's the opposite of multiplying by 3? Divide this by 3. Why can't you do this? So, well, I'm making sure, but still can divide it, so you can get a decimal. This 3 divided by 3 is 1, so we get x is equal to 26 over 3. There's your answer. Do you have a question? You good? Okay. All right. Any questions? Did I go too fast on this? Are we good? We're all good? No questions? All right. Turn it onto the desk right over there. Okay, I will always try to start my lectures off with these two things. Your TEK, which is what the state says you should be learning, and your LO, which is what you guys should pay attention to. Your LO is learning objective, is what I want you to know by the time you leave this class. So if you do not understand the LO, when you leave, you have to come to tutorials, you need to talk to me. Does that make sense? So this is for you, not for me. The top one's actually for me, the bottom one's for you. The TEK is distinguish between undefined terms. The LO is I will learn basic and academic vocabulary such as points, lines, and planes heard during classroom instruction interactions. So, by the time you leave today, what are the 3 terms you should know? Points, lines, and planes. So if you don't know those 3 by the end of this lecture, you need to see me. Okay? In your ISN, I want you to write your name, geometry, Mr. Rink, and period on this first page. I'm going to give you guys like a minute to do that. If you do not have your ISN today, you can either buy one from me or you are going to have to transpose this onto your ISN later. Okay? Your ISNs will be taken up for a grade eventually. Not right now. So the problem is I don't actually have 50 cents. So if you want to buy 2, maybe I have 50 cents. Oh, I do. Here you go. Oh. There's ones there. There's ones there. Yeah. Just pick whatever 2 you like the best. Yes, sir. Yeah. You're welcome. All right. The next thing you're going to do is you're going to start labeling your page numbers. This is 1 after, so the next page is going to be page number 1, then page number 2, and then you're going to label 3, 4, 5, 6, all the way to about 30. On your own, label all of it. It does not have to be done right now. Just try to get to 30. You will also, on page number 2, write table of contents, page number, and title. Okay? You're going to leave the rest of this blank. I'm going to give you guys, I don't know, about 3 minutes to do that. 2.5 minutes. All right. On page 26, you're going to write first 6 weeks. Nothing else will go on that page, so you can write pretty big. I'm sorry? Page number 26. Do we need more time, or are we ready to move on? He's tired. Mm-hmm. What time you go to bed? At 8? You're still tired? Mm. All right. Sounds like we're ready to move on. All right. You're going to turn one page. This is where we're going to start our notes for today. Your notes for today is going to be titled Points, Lines, Planes. Page 27. Okay, the first definition that I want you to write down is going to be called undefined terms. Yeah. Yeah. Points, lines, planes. Okay, our first definition is undefined terms. What are undefined terms? Words that do not have a formal definition. However, you can still describe these words. What I would write in your notes is words that do not have a formal definition, but you can still describe them. That's exactly what I would write in your notes. You do not need to write word for word. Okay? They're your notes, not my notes. So if something makes sense writing it differently, go ahead and do that. This would be page 27, right below points, lines, planes. Yeah, you're going to have 3 examples. There are 3 undefined terms in geometry. They are, can anyone guess what they are? Points, lines, and planes. That's the most important note there. You just have to know what the 3 undefined terms are. For some reason, the CBA loves that question. I'm pretty sure it's also going to be on the test, too. So to recap, undefined terms don't have a definition, but you can describe them. Pencils down when you're ready to move on. That's a big purse. Okay, are we ready to move on now? No, we still have some time. Okay. All right. Who can guess what our first word is going to be? Points. You're right on the point with that one. Thanks. So, one person's got this first blank correctly. Let's see if we can double that. A point is can you guess what it is? That's the next line. A lot? A blob? No. A point is a point. Close. Very close. He's got it. Point is a location. Good job. Second person of all my people to get it. You're like, I was going to say that next. I knew that the entire time. All right. A point is a location. What do I mean by that? Let's look at our Cartesian plane for a second. Oops. What's the location of that point? 2. That point describes this location. Okay. Points, and you guys should all get this one. Points are represented by a what? By a dot. This next one is super duper important, so I'm going to let you guys finish copying down and I'm going to explain it. This next one is something that will show up over and over and over again in geometry. It'll never stop. Good guess, though. Okay. Points are named by a, does anyone know? Good guess. Very good guess. By what? By y equals a? Oh, I'll give you a hint. It's a type of letter. In fact, the second one is actually letter. Here's an example. What's special about that A? Capital letter. A point is always, 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 always labeled with a capital letter. If it is not a capital letter, it is not a point. Okay? If it is not a capital letter, it is not a point. So, how would we label this point? We could either say points A or just A. It's implied. Okay. Are there any questions about this? Nope. All right, here's my question for you then. What's the name of that point? That's a point. It's not labeled though. Okay. If it was this, then the point would be labeled because it would be a capital B. But until that B becomes capital, it is not the label for that point. Okay? We'll get to what lowercase actually means in a minute. All right, who can guess what's next? Lines. A line. A line is made up of, can anyone guess what a line is made up of? Ink. It's a good guess. It's kind of. Points. A line is made up of points. Okay. What do I mean by that? Is that a line? Do these points make up a line? So if I were to start putting points in between each one of those points, wouldn't it get more full? And then what's if I put more, even more? So think of a line as just a series of a ton of points, okay? And they actually go on forever in both directions. Does that make sense to you guys? Okay? So a point is made up of what? Sorry, a line is made up of point. Here's a good question. Let's see how many people are paying attention. This is your own logic skill right now. This is another logic question. A line must have at least how many points? Because you're like, 2, I was waiting. 2 points. The reason why it has to have 2 points is it gives it a direction. That line is different than this line. Actually get it on. You see how the second point is the point that gives it a direction? Okay? You have to have 2 points to describe a line. Okay. Lines have no depth, width, and they do not end. They go on forever. Like this box, right, has a width, a length, and a depth. Okay, a plane does not have, or sorry, a line does not have a width or a width or a depth. It just has a length. Okay, let's think about this for a minute. A line is labeled, or is described by 2 points. Not necessarily X and Y. 2 points. Like A and B. Not necessarily A and B. Don't worry about this part right now. So if it's described by 2 points, what do you think, how many letters, or how many capital letters do you think it has to have? So finish this sentence, Tim. Named with 2 capitalized letters. And what do those capitalized letters represent? The points on the line. Does that make sense? Okay. R1, can someone guess what the lowercase letter? That is why it is so imperative you do not mix up your points with lowercase letters. They become lines. Okay. Lowercase. Let's do some examples. Let's name some of these lines. Well, how would we name this line right here? Right here. A, B. You're going to have to put this little top on the hat. I call it a hat. Put the hat on it. Notice how the hat has 2 arrows on it. Okay? The arrow means lines, as lines go on forever. If you do not put the arrows on there, you're saying line segment, which ends. How would we name this one right here? Both work. You can name this one also BA, this one CA. All of those work. California. I'm from California. Are you from California? Oh, you just like California. All right. Where? I'm from LA, which is kind of close to it. All right. I just added 2 more notations to there, 2 lowercase letters. So what would be another way to label this line, or name this line? R. What's this lowercase letter right here? L. So you could say line L. How about this one right here? Line B. Okay? Do we have any questions on labeling this stuff? Guys, this is not something that will go away. This is not something that you can pass. If you cannot do this, you will not pass geometry. This is the very, very basics of it. Okay? So if you have questions and you're too embarrassed to say anything to me, come talk to me after class and I'll help you. Okay? Next line. What do you guys think is next? Planes. 1 lowercase letter. So it's missing its subject. So it should say lines are named with. So you're right. Planes. A plane is a flat surface made up of, well, right now I want to go to the flat part, so we're going to stop right here. The most common example of a plane is a piece of paper. Okay? Paper is flat. Another example would be like the ceiling. The ceiling is a flat surface. Okay? Yeah, the door is a good one too. Walls are good. Whiteboards are good. Any flat surface. Okay? Made up of, does anyone know what it's made up of? Lines. And now I have a question. What are lines made up out of? Points. So couldn't you say planes are also made out of points? Lines or points. What really a plane is if you take a bunch of lines, you see how this kind of makes a rectangle? Do that an infinite number of times, and that's what a plane is. It's a bunch of lines lined up. So, a plane has no depth. Does this piece of paper have a depth? No. But it will go on infinitely in all directions. You can't ever represent that on a piece of paper, right? So typically how it will be represented is with a rectangle type shape. Sometimes they do like something like this. Okay? That's how they represent it on paper. It's not really a plane though. A plane is made up of at least 3, what do you guys think? Raise your hand if you think it's a line. Raise your hand if you think it's a point. Raise your hand if you think it's both. Raise your hand if you didn't answer. Okay. Let's look at this for a second. This is our plane. This is my line. Is that line on that plane? That's line number 1. Is that line on this plane? Line number 2. Is that line on this plane? No, because this line is giving it depth. So it's not by 3 lines. Sometimes it's by 3 lines if you have them going like all on the same plane, but not always. It will always be made up of 3 points though. Okay? And there's something special about those points that we're going to get into in 1 second. A plane is usually named by a capital script letter. Script means italicized, where it's kind of slanty. So kind of like this. Sometimes they bold it instead. Typically it's in the corner. Or by 3 non-collinear points. That's supposed to be non-collinear. I'm going to give you guys a minute or so to write this down because I really need to explain what this means. Okay? So put your pencils down when you're ready. You guys having fun yet? Tomorrow we're going to do something more physical. I promise. I'm not going to necessarily say more fun. It has to be more fun than definitions, actually. But it's more physical. What? You'll see. I have to hype this up so you get excited. Oh man, I can't wait to go to geometry class. Oh boy. You're like, I did more writing in geometry than I did in English. Okay. I want to break down, what's the one word in here that you guys don't recognize? Or no? Non-collinear. Let's break this word down. Non-col. I'm going to drop an I, or an L. There you go. Okay. What does non mean? Not. No one's got this correct. What does co mean? I don't know why people keep saying to. It's not to. A coworker, yeah. That's what is a coworker? Not multiple. Another sort of, not friend, kind of, same. It means same. Coworker means the same job, right? Okay. Co means same. So let's look at this word for a second. We have not the same, not same. What do you guys think linear means? Line. So non-collinear mean, what do you guys think that means? Not, you guys are geniuses. I didn't even tell you the definition. You got it. Okay. Break down words. In every class, break down words like that. It'll help you. Okay. What do you guys think collinear means? Same line. All right. What about the word coplanar? Same plane. And non-coplanar? Not the same plane. Okay. You just guys learned 4 definitions like that because you broke them down. Okay. So, non-collinear points. They look like this. Well, all right. That's it. Have a great day. You guys have homework. It's 1 through 8 on the sheet.